do you use?
I'm using, okay, the network I'm using is good for Zoom, but I think there are challenges. I think we need to cut this tree. Now, let us look at this. So we have to first get the angle between this plane, CFH. So we have to bisect this plane here, that triangle inside. We have to bisect it into two, such that we draw a line from H up to this point here. Okay, now you should note that FC is the line that is on the plane BCGF. This FC is a line that is on the plane BCGF. And this line, it is a line where this other line HP is meeting. So it meets this line FC at this point here. Now, for us to find the angle in between, we have also to bisect this other plane BCGF. So you can bisect it like this. You get it? Like this. Such that the angle between these lines, this line, the angle between this line and this line here, the angle between this line and this line, the angle between, this angle between is the angle between the planes BCGF and FCH. So that's why I first got this distance here, big G. Find the big G, I used this triangle. And I found the big G. Because I know this part here is equal to this part. So in other words, this is half and this is half to have big G. Are we together? So this is a half and this is a half, a half. So I needed to find the big G. So to find big G, I got it as, if we zoom out, I got it as 16 point this. Now I know that my big G here, my big G is a half of big G. So that's why I said a half times 16.97, and I got 8.5. So it means that, if I zoom in there, it means that this pig here is 8 point what? 8.5. And now this GH is 16, because if this is 16, this is also 16, this is also 16, and also the down there is also 16. So this is 16. And you should know that this line here meets this line HG at 90 degrees. So it means that here I have a right angled triangle PGH. So I'm going to use that right angled triangle and I find this angle theta, which they are looking for, which we want. And this angle theta is the angle between line PG and PH. Why do we use PG? Because PG is on this base, is on this plane BCGF. So this line here is found on this plane BCGF. So the angle between this line, which is on BCGF, and the other line PH, which is on FCH, the angle in between those two lines is the angle between the planes. Yes. So we have to find that angle theta. Esther.
Sure. Yes.
Have you got it? Have you got it? Esther?
Somehow.
What has refused to tell me?
I really don't understand, like how why would you find FP?
Why would I find?
Like the triangle looks cut.
This triangle?
Yes.
This one? Which triangle?
Between P and H. Between P and H.
This one here?
Yes.
This angle?
Yes, P and H.
It looks what?
Yes. Confusing me.
Okay, P and H. You can see that this angle theta at point P, are you seeing it? At point
Yes.
P. That angle is between the line PG, isn't it? You see this line PG?
Yes.
And also a line PH.
Yes.
That angle is in between there. But you should know that the line PG, are you seeing line PG? Is half
Yes.
of big, isn't it? Pig, because
Yes.
this is a square, isn't it? This is a square. So if we have diagonals meet at this point. So that means that if the diagonal is cut to at the center, this side is half and also this side is a half. So big, do you agree that line big D? Do you agree that line big D is on the plane BCDF? Do you agree?
Yes.
If I have BCDF here like this, G is here, B is here, C is here, F is there. Big D is there. It's like that, isn't it?
Yes.
And then P is in the middle there. So that means that for us to get the angle in between this plane here, BCDF, and this other plane here, this triangle inside, we have to draw a line on that plane. You get it?
Yes.
We have to draw the line on that plane. So the line we drew was this one, big. It is on that plane. And also for this other plane, CFH, we have to draw a line on that plane, CFH. You can see that CFH is, if I may draw this, CFH is somewhere like this. It is something like this. So this is point H here. So CFH is this one. CFH is this one here. This is the plane. Inside that triangle there, that is the triangle inside, this triangle inside. So we have to draw a line on it. That line bisects it into this one here. Such that now, this line BG and this line HP meet at the same point. Where they meet, that's where the angle is. That's where the angle of the plane BCDF and the plane CFH is, where they meet. That's where the angle is located. So now you should know that now here it is 90 degrees here. This is 90 degrees. This line and this line here, they meet at 90 degrees. So we have to get this angle theta by using now PG. Do you know that P is at the middle point of big G? P is at the middle point of B. So you have to get PG by dividing BG by 2. And you get 8.5. Are we together?
Yes.
So now what we are going to do is we are going to use this triangle here, this one.
Which one?
PGH, this one.
Picture.
Yes. And we find it.
What if you also use triangle?
Teacher.
You also use triangle HP
HP
B
HP HPB.
B. Yes.
HPB.
Yes, it also works. It also works. HPB. Because now it means that now you have to draw a line from H to what? To B, isn't it? Have to draw a line from H to B, that line there. Okay? You have to draw that line there, H to B. But now, when you draw a line H to B, you have to find that line BH. And that means that you have to also to find the length PH and also BP.
Mm.
You get, and you find, you find this angle here.
Mm.
You get it? Which is going to be a
Yes.
longer way, because for you to find PH, you need to
But
first
you have
find
already found B.
BH is really from
BH
BH.
is found. BH is found. Now the problem is to find PH. Because to find PH, you need to first get FC. Are you listening?
That means BP is 8.5.
BP, yes, it is 8.5.
Mm.
But
Okay.
what you should know is that the angle between this line here and this line here, okay? This is not 90 degrees.
No.
It is not. You get it?
Mm.
It is not 90 degrees. So they are going to use cosine rule.
Mm.
And that is the hardest part, the hardest way to get the answer. So it's better you use this one, whereby this one is already 90 what? 90 degrees. So you have there, the triangle HGP. And at P, that's where we have our angle. That's where we have our angle. So that means that the angle is at point P, and GP is 8.5, and HG is 16 centimeters. So this is what we want. This is the angle we want. This angle theta here at point P. And there we use tan theta, and we say it is opposite over adjacent. So tan theta will be equal to opposite, which is 16, over the adjacent, which is what? 8.5. So theta is equal to tan inverse of 16 over 8.5. And theta will be equal to. Cynthia, what's the answer? Wanji,
Yes, teacher.
what's the answer?
62.02.
62.0 degrees. I remember someone got 62. Alexa, were you the one? Okay, that was the answer. Now, these numbers of 3 dimension, you need to have mastered trigonometry very well, and the angle properties very well. So this was not a hard question, members. This was not hard. Okay. Esther, this was not hard. This was practicing, and then you see how you get to the answer. Okay, so now let us see what we are going to do today. So in your study materials, there is a book called UCE Book 4. So you download it and you go to a chapter called Circles. Are we together?
Yes.
Yeah, you download it and go to a chapter called circles, and then we are going to look at circles or circle properties in the next I think there are 11 minutes remaining. So let us, you know what a circle is, isn't it?
Yes.
But members, with these questions that we've done about 3-dimension, I'm going to add you more questions for you to practice. I'm going to first give you the easiest. Do you remember the other ones of finding the length of a line, finding the angle between two lines? Those ones, easy. And then afterwards, we go to the easiest, where they tell you the angle between two planes. Those will be the easiest. So I will send you the work. I will send you the work by the end
So
of
where?
it will be in the homework. It will be in the homework. Okay. So they are saying that what are circles? What are circles? So a circle has got is just an area. Circles have area. Area of part of a circle. So we are going to see a sector. We are going to see a segment, a minor segment, a major segment, a minor arc, like that. So circles are given. A given circle of radius r, its area is found by using. So the area of the circle is given by. That's the first thing. Area equals to pi r squared. That's the formula. So we are going to look at different formulas, but the area of the circle is pi r squared. And you should know that pi is 22 over 7, or it is 3 point what? 3.14 what? 142. Always write it to 3 decimal places. Members, are you there? Members, are you there?
Yes.
Okay.
Yes, teacher.
Area of a sector. What's a sector, first of all? Area of a sector. And what's a sector?
It's there on the screen.
It is on the screen. Okay.
Yes.
A sector is a part of a circle enclosed by 2 radii and an arc of the circle. Part of the circle enclosed by the 2 radii. So if I may draw for you my circle here, I'm going to show you what a sector is. So there must be 2 radii. Can you mute, please, the one who's giving me the feedback? You want me to hear myself? Okay, like that. Now, what we are going to do is we are going to draw 2 radii, not radiuses. Cynthia, we call them radii, yeah?
Hey, Java said radiuses.
Okay, 2 radii. No, that's what you thought it was, but we are going to do 2 radii. So the first one is this, and the second one is that. And they are equal they are equal because they are radii. So the radius is the same. As long as this line drawn from the center is touching the arc, it is always of the same length with the other lines coming from the center touching the arc of the circle. So we have a sector. So we have, first of all, this one which you see, the bigger one which you see this side, is what we call the major sector. This one is called the major sector. Are we together?
Yes.
And this one is called the minor, the se, the minor sector. Now, this arc that you are seeing, if I may label, this is A, B. This is 0 here. So this arc that you are seeing from this other side like this, from there up to there, this arc which is this side, this arc from here up to this side is what we call the major arc. It's called the major arc. That's the major arc. Then this one automatically becomes the, this one becomes the what? The minor arc. The minor arc. Okay. So if there is an angle theta, if this is the angle theta between these two radii, like that angle theta, and this angle theta is, it is a reflex angle because it is beyond 270. So it is, I mean, it is beyond 180. So it is a reflex angle. So this angle theta here is the angle that subtends this arc by the two radii. So they are telling you that a sector is part of a circle enclosed by two radii and an arc. So this is a sector. Even I can shade it. This is a sector. This one here. This is the minor sector. Then the other one is the major sector. This is the major sector. So if an angle subtended by the major arc at the center O, then the area of the major sector is given by theta over 360 times pi r squared. So what are they saying? That if you want to get the area of this, this is the area of this, of the major sector. So to get the area of the major sector, area of major sector subtended with an angle theta, from here up to here, it is theta. So it means that to get that area A, we have to get the theta divided by the angle sum at the center, which is 360, then times the area of the whole circle, and the area of the whole circle is given by pi r squared. So that gives you the area of this part here, which is unshaded. So that is the unshaded area that you are seeing there. Is the unshaded area there. It is the major sector. And if you want to get the area of the minor sector, area of the minor sector, it means that you have to get this angle here. If this angle is theta 1 altogether, then it means that the area is going to be theta 1 over 360 times the area of the whole circle, which is pi r squared. That gives you the area of the minor sector. And this one gives you area of the major sector. So there is an example. Are we together, members? Yes? Are we together? Okay. So we have a question there, and they are telling you that a circle has radius of 18 centimeters. So the radius of that circle is given by...
Teacher.
Yes, dear.
Teacher.
Yes.
Can you please zoom in a little?
Like that.
Yes.
So there you can see that for the area of the major sector is given by theta over 360 times pi r squared. So it means that this is the theta, this side is the major sector, this unshaded is the major sector, is the unshaded area. So you have to get theta divided by 360. Why 360? Because the angle sum on this at the center is 300 and what? 60. So theta for that major sector out of 360 times pi r squared. And also to find the area of the, for us to find the area of the minor sector, we have to get the angle which is inside here. So the angle is theta 1. That is the angle of the minor sector, this one here. So it will be theta 1 out of 360 times pi r squared. Is it okay?
Yes.
Okay, so now let us proceed. They are giving us a question there, and what are they saying? So they are saying that a circle has radius. So there is a circle which has radius r of 18 centimeters. They're telling you find the area of the sector of the circle whose arc subtends an angle of 70 degrees at the center. So the angle they are giving us is 70 degrees. And they are telling you to take pi to be equal to 22 over 7. So they're asking you what is the area of the sector that is subtended by the two arcs that make an angle of 70 degrees at the center. So to find the area of the sector, we shall say very easy. So it is theta out of 360 times the area of the circle. And the area of the circle is pi r what? Pi r squared. Are we together? Yes, are we together?
Yes.
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 So I'll substitute and we say 70 out of 360 times pi, but our pi is 22 out of 7, then times the radius times 18 squared, but 18 times what? 18. That's what it means. So when you cancel this and this, you get 10, isn't it? Eh? Should we continue canceling? Are you ready? Are you ready? So 22 divided by 2, you get?
11.
You get
11.
360 divided by 2, you get?
180.
You get what?
180.
180. So 180 divided by 18, you get?
180
Divided by 18,
10.
you get 10.
10.
And here divided by 18, you get what? 1, isn't it?
1.
So 10 divided by 10, you get 1.
1.
Okay, now what are we left with? We are left with 11 times what?
11 times 18.
11 times
We
18.
shall have 11. Shall have 11 times 18. And what do we get after multiplying there?
198.
198.
Yes.
198 centimeters what?
Squared.
Yes, because you are finding the area. So that's the answer, which is here, 198 squared. And then the other thing that is part of the circle that you should know is what we call the circumference. Circumference is just the distance around the circle, or the perimeter around the circle. So circumference. So circumference C is equal to pi d. Pi times the diameter. But you know that, but diameter equals to 2 times the radius, isn't it?
Radius.
So it means that circumference is equal to pi times 2r. So sometimes someone writes circumference is equal to 2 pi what? 2
2
pi
pi r.
2 pi r. So you can use this, or you can use that to find the circumference. Then, how would you get the length of an arc? So if I take you back to our circle here that we had,
Yes, teacher.
we are going to do the circle again. Very easy. Just know that we have. Okay. So we have it there, and let us draw the sector. Now, if inside here, this is the angle theta, and this is r, the radius, this is point O. Now, this distance that you are seeing here, we say that this is what we call from here up to here, is what we call the arc, the minor arc. So we can get the arc length from here up to here, that distance from here up to here. The arc length is just part of the circumference altogether. So you're looking at the arc what? Arc length, which is part of the circumference. Arc length, part of the circumference. So this one here is what we call the arc length. The arc length, just part of the circumference, and it is noted as L in most cases. So to get the arc length of this point, remember this is a sector here. So the arc length enclosing that kind of sector here, this distance from, we call it from A to B, that distance there, taking this side. So to get that distance, the arc length L, we shall say that L, okay, here they say arc length L. Arc length L is equal to theta out of 360, then times the circumference. So it is the theta out of 360 times 2 pi what? 2 pi r. 2 pi r. So that is the formula you can use to find the arc length. Now, if you want to find the length this other side, then you have to get the angle, which is this side. Get it? Members, are we together?
Yes.
You have to get the angle, which is this side. So that will be the major arc. This is the major arc, and this is the minor what? Arc. So if you want to get the length of the minor arc, use this angle theta out of 360 times the circumference. Are we together, members? So members, Cynthia,
Yes. Yes.
and the rest, allow me to stop here for today. When we meet next time, we shall look at more about these circles. They are very interesting, and we shall do these circles and finish them such that at the end we have finished every topic. So thank you very much for joining. May God bless you, and always get tuned up. Check the recent videos and you watch and you understand all the things. Have a nice day.
Okay, bye.
Bye-bye.
Bye.